the past, we have talked about autonomous and connected technologies. We've talked about women leaders in the mobility industry, AI efforts, and a whole lot more. So as I said, this is our first live session for our Chat the Expert series. So this will give you a great opportunity to hear from Tim, Daryl, and Dan virtually in person. And if we run out of time, we don't get to your questions or comments, you can continue the discussion in Member Connection. There's already a whole lot of good stuff there. So that is connection.sae.org. You can also include that in the notes section. And you can, that's there, you just have to sign in with your My SAE account login. One more quick pitch. Dan will also be participating in a webinar, our Move with Mobile, next month on the 18th to discuss this very topic, vehicle dynamics, as well as his upcoming book. And I will also put the registration link in the notes section. And with that, I will stop talking and I will pass it on over to Tim to start us off with introductions.
All right. Thanks, Corey. Yeah, my name is Tim Drotar, and I'm a vehicle dynamicist at Ford Motor Company. I've been at Ford almost 30 years. It'll be 30 years at the end of this year, and my experience at Ford has all been in vehicle dynamics and chassis systems. So I'd like to say I've been fortunate enough to go up and down the systems engineering V. So doing a design and release of design engineering for suspension and steering, chassis systems, which is setting up the suspension hardpoints, compliances, things like that. Full vehicle simulation using Atoms for ride steering and handling, and then also I was a development engineer, ride and handling development engineer on the F-Series platform for about 5 years. So one of the things we've talked about in the chat, is this idea of experience in simulation, testing, objective testing, and subjective evaluation, and being able to merge, use all three of those tools at the same time. Currently, I'm working in the automated driving and driver assistance research team, so primarily focusing on simulation tools for driver assistance technologies. That's it.
Go next. All right, Daryl, why don't we get on over to you? We'll keep it alphabetical.
Okay, I'm Daryl Hancock. I've got about 35 years of experience in vehicle dynamics or very closely associated areas. Worked for a number of different companies, from tire manufacturers to race teams to OEMs. I'm currently at Stellantis, the car company formerly known as Chrysler. I've been here about 25 years, almost all of it in vehicle dynamics or chassis. My main focus now is on kinematics and compliance. I process all of our data, and I also am heading up a global initiative to combine all the kinematics and compliance testing across Fiat, PSA, Chrysler, everybody. I'm, I guess, a real vehicle dynamics enthusiast. I've done it pretty much my whole career. Have a lot of experience in testing and measurement and subjective evaluation. I think that'll do it for me.
Perfect. Thank you, Daryl. And Dan, if your technology is working, please go introduce yourself as well.
Okay. Yeah, thanks a lot for that. I kind of slide in the window in between Tim and Daryl. I've got 34 years of experience. I started out working on passenger car active suspension. Did that for about 7 years, and then I moved over to commercial vehicles. And managed the advanced engineering group of the old TRU commercial vehicle steering unit in Lafayette, Indiana, where we did what we think is the first sort of synthetic torque field steering system. They're a little bit more common on the market now. We did one back around 2005 for a limited vehicle launch, a sort of a high margin, low volume niche product in motorhomes, transit buses, military specialty vehicles, things like that. So since roughly 2017, I've been working more on ADAS and autonomous driving, and I currently lead the ZF North American commercial vehicle ADAS and autonomous driving efforts. So thanks a lot. I've enjoyed the online chat so far today and looking forward to this discussion this next hour.
Perfect. So yeah, I'm gonna throw it into, you know, guys, you three, your side of the field, and just, you know, how you want to drive the discussion, you know, whether you want to talk about the book, whether you want to talk about some of the things that, you know, you're talking about in member connection, wherever the road takes you, my friends.
All right. I guess question is, you know, how many people have read the book, like the first book? You know? Can we do a thumbs up, a show of hands, or like this? Yeah, because I tell you, there are two, you know, so there are two references that I kind of cut my, well, three references that I cut my vehicle dynamics teeth on. One of them was Gillespie's Fundamentals of Vehicle Dynamics. The other one was a GM paper by Tom Bundorf and Leffert. Bill Leffert. Oh, yeah. It was the cornering compliance concept for the description of vehicle directional control properties. And then the third one were some old papers from the 30s, Maurice Olley's collection on ride. So those three, you know, together really form a good foundation for your study of vehicle dynamics for those of you who are just getting into it. And then, you know, once you have that basic background, then pick up race car vehicle dynamics if you're interested in that, or some of the more, you know, the more advanced books. So what about you, Daryl? How did you cut your teeth?
Actually, initially there were very few vehicle dynamics books in the 80s when I was in college and working on Baja SAE vehicles. So I did a lot of digging here and there. There was a book called Mechanics of Vehicles, and it was a compilation of articles published in Machine Design magazine. And I didn't have the money to buy the book, so I went to the library at school and copied the articles out of individual issues of Machine Design, and that was kind of my Bible for dynamics. Then I can remember before the Fundamentals of Dynamics book was published, Tom Gillespie, through the Detroit SAE chapter, kind of presented it, maybe as a dry run for his video class or whatever. And I remember going to those and taking a ton of notes that I still have somewhere. And then eventually the Fundamentals of Dynamics book came out, and that's been my go-to book, you know, for 30 years now. I actually have 3 copies of it. One copy in my office in Auburn Hills, one copy in my office at the Proving Grounds, and a copy at home. So I've been a big supporter of Dr. Gillespie and SAE with my purchases. And it's pretty exciting to see the new book come out, although, you know, everything that's in the old book is still there. It just is maybe a little enhanced and a little more in depth. There's really not that many fundamental differences because the laws of physics haven't changed. The principles of vehicle dynamics are still the same. So I'll throw it to Dan now.
Yeah, well, I guess the main thing I would add to that great list that you guys already put together is a book by an older guy, and in Daryl, and this might go back to the 80s when you said there weren't a whole lot of good books. There was one that I found called Vehicle Dynamics by a guy by the name of J.R. Ellis.
Yeah.
And that is a book that really takes sort of an engineering mechanics view of vehicle dynamics. And it's probably been kind of the biggest influence and the biggest guide on the stuff that I've done. And I really appreciated what Professor Ellis put together in that book. And I would encourage anybody that wants to have maybe a little bit more of a rigorous view of vehicle dynamics. I mean, Ellis goes through and he starts, with a good look at reference frames, and just kind of takes it through there. And for those of you that are maybe familiar with the bicycle model, there's a lot of simplifications on the bicycle model that we just kind of take for granted because everybody kind of uses the same thing. But when you go through Ellis's derivation of reference frames and the accelerations and translating and moving reference frames and that sort of thing, you really are able to see all of the assumptions that we kind of just implicitly accept in the bicycle model. So I think that's a good book.
Yeah, I was never able to get a copy of that when I was in college. I was aware of it, but could never find it.
It's funny, I had a Xerox copy of that from my thesis advisor in college, and I was using that for a while, and I was looking on Amazon to try to get a used copy of that, and I had this number that I would accept, and I was finally able to find a really good used copy of that for like $70, and boy, I thought I stole something when I got that.
Yeah, I got to tell you, I agree with you there, Dan. And actually, where I found value in that was, when the SAE Trailer Tow Standard was being developed, and as an OEM trying to figure out, how we're going to meet this, that came in handy to develop because it has a derivation of the bicycle model with extended to a trailer, and so taking those equations and putting it into MATLAB and developing a simple model of a car plus trailer, truck plus trailer was very very useful and eye opening. So yeah, there's a quote that I like that says if you want to learn something new, pick up a book that's 100 years old. Because that's true. It's especially in the field of vehicle dynamics. I mean, it goes back to the turn of the century, as soon as they started having four-wheel cars,
All right, well, I think we have some questions going on here. So first one, I don't know, Alan, if you just want to ask it yourself, or if you want me to read it, whichever way.
Let's see, I think I just unmuted myself.
Yeah, we can hear you.
Okay, so I guess I'm thinking back to my college experience where there wasn't really a dedicated vehicle dynamics curriculum. I ended up learning it on the job. So I guess the question is, at the college level, do you see an increase or decrease in the available offerings, if any?
Yeah, my just working with universities, there are universities that have, vehicle dynamics courses. I know all of they will have an undergraduate course in vehicle dynamics. But I wouldn't say that it's 100% like every engineering school. I guess it all depends. The local ones here, like University of Michigan Dearborn, Michigan State, Lawrence Tech, I know they all have in the Detroit area have undergrad classes. But the other thing too is that one could surf the web and get class notes from Purdue or some other universities and use that for their investigations.
Yeah, that would be a new option that was not available back in the days of stone tablets when I was in college.
Yeah, but like you, I didn't have a vehicle dynamics class in college back in the mid '80s, and what I learned was on the job. You know, somebody handed me the Bundorf paper and said, "Here, read this." You know, and that was
That's
it.
very much how it happened for me back in my GM days.
Yeah. Yeah.
Well, I was lucky enough to have a vehicle dynamics class in college. And at a big school like the University of Illinois, I would say even with that, there was maybe, I don't know, 10 people that enrolled in that class. It was offered once a year. I've had a chance to teach a similar class at Purdue off and on, and I think they offer it when I've taught it, and I don't think since I had to kind of drop out because my job demanded a little bit more travel. Well, I don't think that they've taught it since I've quit.
All right. Let's move
Yeah, I
on
think
to another question.
oh,
Oh, go
just to continue on with that, is SAE has a really good, not to pat ourselves on the back, but I think we have a really good vehicle dynamics curriculum. And so, as Daryl mentioned, the applied vehicle dynamics is a great hands-on course. The advanced vehicle dynamics class and the fundamentals of vehicle dynamics classes are really really good. And then there's other steering systems, brake systems, and so forth. So there's an opportunity there for some a good curriculum.
I hear they have a really good instructor for those seminars. Sometimes they even get good substitutes to come in too.
That's right. Well, when they pay them. Now, James Walker he sets the bar really high because he has he does the applied vehicle dynamics course, and he has a series of brake controls courses as well, and he knows how to juggle, so that keeps the students entertained. So none of us. I teach the steering course and the steering systems and advanced vehicle dynamics, and but I don't know how to juggle, so not as entertaining.
okay, you can learn your next party trick. All right. Al Iskakov, I hope I'm saying your last name right. If you want to ask your question.
Oh, hi. Can you hear me?
Yes.
Oh, okay. Yeah, my question was, if you're trying to learn vehicle dynamics, what are some of the supplemental knowledge you'd say is useful? And the second question is, say you're already, like, say, out of college, and you're trying to learn vehicle dynamics in a practical way. Let's say using your free time, what would you suggest doing? Kind of connect the theory to practice.
Well, one of the first things I would suggest is get familiar with the fundamentals of dynamics book, and then go out and whether you're driving or riding in a car, think about some of those things. For instance, with respect to ride, right? Can you feel the pitch of the vehicle when the front wheels hit a bump and then the rear wheels hit a bump? Can you perceive when the unsprung mass is moving versus when the sprung mass? That will really connect you to the calculations in the book to what you feel in the vehicle and what's meaningful, right? The book is just a tool, and all the calculations in it's just a tool to try to make a better car.
Yeah, I'll second that. Like you go to the section on, for example, steady state cornering in the book, and Gillespie talks about this concept of the lateral acceleration gain. How many G's of lateral acceleration you get per normal. I think it's normalized to 100 degrees of steering angle or G's per degree of steering wheel angle. You know, so go out, you know, in your car and obeying the speed limit, you know, maybe do start doing a gentle lane change where you apply a slow steer input into one direction and kind of feel, you know, okay, how much, you know, lateral acceleration am I feeling in my body, you know, per degree of steering wheel angle, you know, start to develop your sensitivity to the kind of things. Or steering wheel torque. How much steering wheel torque does it take to, you know, for a given steering wheel angle? You don't necessarily have to go out and put a helmet on and race around a race course. You know, these are things that you can do, you know, legally on public roads. The other thing is things like, you know, autocross. You know, find some, you know, local SCCA, you know, group. You know, will have autocross events where you can take your personal car and, you know, put on a helmet and drive through, you know, do the best of your ability, drive around a course, and the only thing you have to worry about is avoiding the cones. You know, that's a good way of getting some, you know, some seat time to be able to, again, you know, hone your evaluation skills.
Thank you.
I'd like to ask a question on the vehicle dynamics that I'm interested in. I'm an optical engineer working ADAS at Farmington Hills, and I'm interested in how that affects the camera. And I'm wondering if, rather than go through a tome like Gillespie's, is there a short 50,000 foot view of vehicle dynamics where I can see the frequencies and the angles? I know from experience from what Tim had said that you can, when you hit the brakes, you can feel the car pitching forward. I know that when you take a turn, that the car will sometimes rotate counter to the turn, that you're going to the right and the car is pitching to the left, and that type of thing. But is there a short view for a guy like me that does not need to get down into the guts of things?
Anybody? Well, I think that the beauty of Gillespie's book is that it's, you know, things are the concepts are presented in a very simple way. Does a very good job of taking complex, you know, a complex topic and distilling it down to the, you know, what you really need to know, the first principles. And so, for example, the braking one, let's take the case of braking. He gives some very useful equations that you could do spreadsheet engineering to figure out, you know, how many degrees of pitch you get per G of deceleration, you know, from a first principles standpoint. And you could use that to get a feel for, okay, if I'm braking at 1G and I have a certain wheelbase vehicle and a certain CG height and, you know, some assumptions for the front and rear spring rates, you know, this is how much the vehicle is going to pitch. And so you can get some really good insight by flipping through the pages of Gillespie's book. So
the only thing that I would recommend before Gillespie's book would be, and I think Daryl, you mentioned it, that kind of series of papers that Tabarek did on sort of vehicle mechanics. You know, I think that could be helpful, but I mean, I wouldn't really say that is like any sort of more fundamental than what Tom's book is. I think it's maybe just a little more sort of condensed.
Yeah. There's another one too. You can get this one off of eBay. It's called you ever seen this one? The Chevrolet Power Service Manual. And there's a section in here on vehicle dynamics. and they wrote it for the purpose of the guys working in the service bay. There's a whole like nice section. But yeah, Chevrolet Power Service Manual. I found this copy on eBay. There's a nice 20, 30-page section on vehicle dynamics that goes through like all the fundamentals. So might want to.
Wow, that's a powerful recommendation from a Ford guy.
Well, you know, I did start my career at GM because I was a co-op student at Saturn. So and forgot to tell that part because I was doing instrument panels, plastic trim parts, and I had one co-op rotation in chassis, and they handed me all these good GM internal documents and on vehicle dynamics, and that's what got me hooked. So it's kind of where I got it from. So
Awesome. All right, so let's move on to Nicholas, and then he can be followed by Stuart with your questions.
So I'm looking into determining an ideal torsional rigidity for a frame. Are there any good methods for doing that?
well, so the first one would be if you had access to a static torsion test rig, where you clamp the frame at one end and apply a torque at the other. That's the physical. And I'm probably oversimplifying it, but that's kind of the probably the easiest way that it's done, or most common way that it's done in industry. The other way then obviously would be some kind of finite element modeling, and start with a very simple ladder type frame, and then go from there.
So I've been able to do both of those and validated the FEA model. However, I'm looking into figuring out what my ideal torsional rigidity should be as opposed to like what the actual torsional rigidity is. So I'm trying to figure out what would be a good method to set a target.
So the target, is probably going to be something that's some vehicle level target that you're going to cascade down to the, through the system level, and the system being the chassis system, and then down to the component level which is the frame. So you might start with some target for, torsional frequency of the entire vehicle. And then say it's a body on frame. I'm assuming it's a body on frame, right? So then there's some contribution of the bed and the cab, and then some contribution of the suspension, and some contribution of the frame, and do some kind of decomposition to figure out.
So it's actually for a Formula SAE car.
I think there's a paper on that.
There's a couple of papers on that.
I've read the one that was done by somebody at the University of Michigan, but it didn't seem to go into enough detail. And the validation process they used seemed incredibly difficult and time consuming. I wasn't sure if there was a better method like to be able to do that, because the rule of thumb I've always heard is 90% or you want 90% stiffness. But I wasn't sure if there was a better method than just going by a rule of thumb like that.
Like I said, given the fact that you have a validated FEA model, like I said, whenever we're doing any target setting, it always starts at what is our target at the vehicle level, and then we cascade those down the systems engineering V. So you got to, ask yourself, okay, what are the subsystems that contribute to the total, to that vehicle level metric? And then for each one of those subsystems, break them down to the component contribution. So.
All right. Well, again, if you want to continue the question or ask a little bit more detail, or let your other people think about it. You can also access the member connection, so don't forget about that.
Yeah, if you, I'm sorry, Corey, if you, post that question, or if it's already posted in the member connection, we can, I've got some, I could give you some, reference papers some other reference papers on, frame torsional stiffness that might be useful. So.
All right, let's go to Stuart, and then we'll go to Stephanie Schultz.
So assuming that's me, Daryl, question for you. With your growing experience at Stellantis and working on the KNC across the group, are you seeing much difference in the way that things are done here relative to there? Here being US, I mean. Odd accent for here, sorry. But
actually, I see very little. It's been very surprising how much things are the same. There are some differences because there's different test equipment, primarily MTS and Anthony Best Dynamics, which dictates a little bit of difference in the test procedure itself. But everybody has developed their own procedure, and it basically comes into putting loads into the vehicle and measuring displacements, whether angular or linear, out of it, and they're amazingly similar. You would think we had been in cahoots with Fiat for many years. Our test procedures and our results are so similar.
Cool. I know I've seen some over the years, I've seen some really odd contraptions, particularly not in Stellantis group, but some other European manufacturers that they try and add some numbers together, and you're thinking, yeah, that doesn't go like that.
Yeah, we had a couple of different homemade contraptions in the Chrysler years. One at Jeep and Truck Engineering down in Detroit, and another one at the Proving Grounds in Chelsea. But I think now the market has shifted primarily towards either an MTS or an Anthony Best machine. They sell pretty much a turnkey solution that's a mature product and works pretty well.
Cool. Thanks.
Yeah, these kids don't know how good they have it these days. Back in my day, we had to do a bump steer test or a camber gain test using an alignment rig, a tape alignment machine, and a tape measure.
And a jack.
And a jack. Yeah, exactly. These kids today.
You're showing your age, Tim.
Yeah, I'm like an old man that's sitting on a park bench feeding pigeons.
All right, Stephanie, you want to go ahead? And then that will be followed by Josh DeWald. I think you're on mute, Stephanie.
Can you hear me now?
Yes.
Yes.
I had an opportunity to sit on some state, specifically educational classes within rail. And rail is slightly different than vehicle because many, not all, but of the wheel-rail interactions, say, have dedicated routes. They're within grade, like mountainous terrain. There's an opportunity to increase or improve contact between obviously the static structure and the dynamic structure. And there's some grant and poverty programs available through the Department of Transportation that allow or enable or support existing technologies to be from other transportation segments to be applied within rail. So one of the areas of opportunity potentially could be is the active dampening system, which obviously improves the vertical dampening between the various tires and achieves the lateral cabin height for the use of earth magnets and liquid suspension. I was wondering if we could consider scaling an existing technology, but applying it to considering applying the concept to a different technology in order to reduce spend. So in order, an effort to improve basically where the tire hits the road. So is there a proper process or a proper, I could see Hitachi's going from car to industry. I can see a few of the supplier-owned designs are looking to broaden or maybe interested in broadening their customer base. Is there a specific process, although most of the know-how has been developed by OEM in coordination with SAE or JIS, is there a specific process to follow if we were interested in adopting or considering some of the technology for an older industry?
Yes, I don't know of any specific process or case study or anything like that of applying active or adaptive damping to any vehicle, whether it's a rail vehicle, off highway, automotive vehicle. But it's basically, you have a spring mass system and you want to dampen it, you want to minimize the forces transmitted, you want to minimize the accelerations transmitted. I think one advantage you have in rail is you don't have all the tire characteristics, right? The wheel is a pretty fundamentally rigid piece rolling on a relatively controlled surface. You don't have potholes and speed bumps and that sort of thing on your rails. So the damping requirements are probably somewhat different than what we look for in a car or a truck or something like that. But I think it would probably be an easier tuning exercise in a rail car. You would have a much more pure motion, right? The mass of the rail car on the spring of the suspension without a lot of secondary elements in there. You don't have a tire that acts as a spring. You have a relatively controlled range of inputs going in.
I mean, the limitation obviously would be the load. I was specifically thinking of freight. So we've got some protected rail out west, and the grades between one, let's say above 1.5. I understand, there's some challenges obviously between, much like heat or, maintaining the surface of an external tire. And when it comes to, the grain boundaries, there are some similarities in the tires to the rail in terms of grain boundaries and cracking. There's obviously some similarities in that interaction. But at the end of the day, maximizing adhesion, maximizing the contact area is beneficial to both parties, minimizing any hydroplaning or any contact with any icy surface. But as a win-win, and trying to keep our heavier loads off of the road, no one wants a lot of grain on the road or a lot of coal on the road. And everybody is trying to minimize the amount of foul. So the active dampening system, with the use, some of them with the use of electromagnetics, might actually be able to have a smaller, more managing packaging size in order to basically have the haul carriage counter rotate above the wheels. The envision would be to have, with the use of obviously some software, and the intent is to centralize the center of gravity laterally and vertically in order to minimize the load-bearing difference between the left side wheel set and the right side wheel set, or the left side tire and the right side tire. Minimize the propensity to roll, which would be no different than on a car on a corner.
Stephanie, I'm sorry to interrupt in the interest of time. We have
So
a
is there a
minute.
specific process that SAE, in order to respect the industry, there have been, about a month ago, there was an opportunity for grants across industry. Is there a process to request SAE or a way to respect that within SAE?
Stephanie, I am going to ask you to continue the discussion or the question, hop on over to Member Connection, and maybe we can get some more input from other people in the industry. I know we are running short on time. So if everyone can kind of stick around, if you want to stick around, if you can, for this, that'd be great to get a few more questions in. Because I know we've got a ton of stuff in the comment section going on right now. And I know everyone is so busy. So I don't know, what do you think, you three, Tim, Daryl, and Dan, if you can stick around for like 5 more minutes, or if not, totally understandable. Okay, well, why don't we go to Josh's question? I thought he had a pretty good one. I'm just going to read it, if you don't mind. But how do you guys think the application and study of vehicle dynamics will change with the adoption of autonomous vehicles, if at all?
So that's a question that's been asked several times in the Member Connection forum today. And on the one hand, I've said it doesn't change, right? The principles didn't change. Isaac Newton didn't wake up and change any of his laws. It's all the same. Everything operates in the same way. But I think with fully autonomous, self-driving vehicles, the focus is going to shift away from steering and handling and more towards ride. When you have people that are just riding along in a vehicle, they're not engaged in the driving task at all. They're going to expect a better, a quieter, a smoother ride so that they can do other things. They can watch a movie, they can answer their emails, that sort of thing. So I think ride will become more prominent, and steering and handling will be less important, still important, but less so. As long as the vehicle operates predictably such that the control system can manage it, then it's okay. The control system doesn't have a preference for a sporty vehicle versus a relaxed vehicle, right? It just wants to make the vehicle turn left, turn right, follow a desired route. But that's probably a question that Dan might have some more insight on.
Well, if I could chime in on that, it was my question. I was kind of thinking that might be the case in terms of commercial passenger vehicles, but for things like fleets where there's freight involved, where there may not be any people in the vehicle at all, I was kind of wondering more so where that might be headed.
I think kind of in the same way. I mean, there won't be an increased focus on ride, but ride is still important. You don't want to transmit any undesirable loads into your cargo or your payload.
Makes sense.
Yeah, I think that's right, Daryl. I think it's a really interesting thing to try to think about, how our field is going to change as this, just sea change in technology occurs. And you can say that we're taking the driver out of the system, and that kind of, changes some of the controls to the vehicle and some of the feedback the vehicle would give to a driver or a virtual driver. And that's fair enough. But one of the things I think that we really haven't thought enough about is, the driver does more than just kind of, control the vehicle. And especially you were talking about the commercial fleets. I mean, we expect the drivers to be able to diagnose issues in the vehicle, determine when the vehicle needs to be brought into service and that sort of thing. I've worked for a while in steering, and things like steering lash, is something that is pretty apparent to the driver. And we need to be able to build these kinds of sort of diagnostics into the virtual driver, and I think they'll have some reliance upon vehicle dynamics to be able to do that. And the other thing, where I think there's going to be a bigger demand for vehicle dynamicists in autonomous vehicles is when it comes to what our vehicles do in sort of emergency maneuvers when they have to choose between sort of viable outcomes. I read a while back by Gary Kasparov, the former Russian world chess master, and he was talking about how it felt like to play chess against a computer. And one of the things that the computer obviously had is, and it was a scale of computation power, is how many steps out in the future the computer could evaluate every possible scenario. And our autonomous vehicles are doing that kind of thing where they're seeing potential interactions with other traffic, and they're trying to determine what, as they refer to it, as the minimum risk scenario is, given the information that they have. And of course, your minimum risk scenario heavily depends upon your own vehicle dynamics, and also, if you can determine it, the vehicle dynamics and the vehicle dynamic condition of the other people on the road. So, you can say that we're taking the driver out, and maybe some things that we typically look at in vehicle dynamics aren't going to apply to autonomous vehicles. But there's going to be, I think, a whole host of new problems for vehicle dynamicists to tackle with autonomous vehicles that we've really just kind of scratched the surface of.
Yeah, I agree with you, Daryl and Dan. If anything, I think it's going to be even more important for the next generation of mobility engineers, to have at least some kind of understanding of the fundamentals of vehicle dynamics. How a vehicle starts, stops, and turns. Because without that, I think one would have a hard time, developing some control strategy to be able to make the car, stop, start, turn, and be robust to error states. Hey, Stephanie, or Corey, I think you're muted.
Technology, I swear. This must be a millennial. I should be able to do these things. But I figure we could probably get in like one more question, as long as you don't have to jump off and go to other various things. But Pedro, Caloria, if you'd like to go and ask your question.
Yeah, so basically my question is, we see a lot of people doing quasi-static lap time simulation, which uses the limit performance envelope as a principal tool to evaluate the car at each condition. And my question is basically, I wonder how transient effects such as the inertors, dampers, and inertia could affect such surface, and what are the impacts that could influence this analysis?
Well, if you want to think on a little bit, we can definitely move that one to member connection as well.
Yeah, that's I got a number of different answers.
Okay, yeah, Pedro, if you wouldn't mind, if you haven't already asked your question in member connection, why don't you throw that question into the discussion thread so they can think on it a little bit. How does that sound?
Yeah, of course, but the question was clear. Maybe you want me to repeat, or?
Yeah, why don't you repeat it?
Do you want me to repeat here or in the other section? Because it would make sense. Maybe.
Yeah, why don't you put it in the other section? You know, then we can give you a proper response.
Yeah, okay.
Okay,
Sounds good.
Thank you. Yeah, I mean, we are about 10 minutes over time, and I want to be mindful and respectful of everyone's schedules. I only originally scheduled this for about 45 minutes just because I honestly wasn't sure about the reception or the response or the participation, but overwhelmingly a lot more than I thought, which I'm very happy with. So, I want to thank you guys, Tim, Daryl, and Dan, for taking time out of your busy schedules to do this with us and to also chat with our members in Member Connections. So, I see we have a whole bunch of other comments, a bunch of questions. So again, please go to Member Connection, which is connection.sae.org, and you just sign in with your My SAE account. It should be a single sign-on. And take your questions, continue the discussion there, talk with our other members, with some other non-members perhaps. And yeah, just keep on keeping on. So any last final thought to round out the discussion today?
Well, I think there were a lot of good questions, and certainly food for thought, made me scratch my head a little bit. So I appreciate everybody's participation there.
Yeah, I'll second that. Great topics, and I always love talking shop. So
Yep,
good.
appreciate the excitement in the audience for sure. Thanks a lot for tuning in.
Yep.
Yeah. All right. Well, again, go to Member Connection. Check out Dan next month in our Move with Mobilist webinar. And thank you so much, and look for future chat discussions. Okay. Take care, everyone. Have a good day.
Thanks.
Yep.
Thanks.
Thanks.